In the year 2021, humanity placed the most complex machine ever conceived onto the top of a rocket and fired it into the dark abyss. We did not build this machine to look at the stars. We built it to look through time. We believed we knew how the universe was born, how galaxies were formed, and how the story of everything would eventually end. But the universe has a way of shattering our illusions. When this new eye in the sky finally opened and peered into the deepest edge of existence, it did not confirm our theories. Instead, it sent back a quiet, terrifying warning. It found things that simply should not exist. And it proved that everything we thought we knew about the origins of reality was fundamentally, completely, and undeniably wrong. This is the story of the James Webb Space Telescope and the crisis it has unleashed upon modern science. To understand the magnitude of what has been discovered, we must first understand the absolute miracle of the machine itself. For decades, the Hubble Space Telescope was our primary window into the cosmos. Hubble was a legend. It showed us the universe in ultraviolet and visible light, the exact same wavelengths that the human eye evolved to see. It gave us breathtaking images of nebulas and distant galaxies. But Hubble had a physical limit. It could only see what was shining. It could not see what was hiding. The oldest light in the universe, the light from the very first stars that ignited out of the primordial darkness, has been traveling through space for over 13 billion years. As the universe expands, the very fabric of space stretches, and as that space stretches, the light traveling through it stretches along with it. A photon that left its source as ordinary visible light billions of years ago arrives at Earth stretched so far that it falls completely off the visible spectrum. It becomes infrared light, invisible to Hubble, invisible to us. Therefore, humanity needed a new kind of eye. We needed a telescope completely dedicated to capturing the faint, invisible glow of ancient heat. But building such a machine required engineering that bordered on science fiction. The James Webb Space Telescope features a primary mirror measuring 6.5 meters across. That is more than 6 times the light-gathering area of Hubble. It is not a single piece of glass, but 18 separate hexagonal segments forged from ultra-lightweight beryllium and coated in a microscopic layer of pure gold. Gold is the perfect reflector for infrared light. But this massive golden eye presented an impossible problem. It was simply too large to fit inside any rocket on Earth. And so the engineers did the only thing they could do. They designed it to fold. The golden mirror folded. The secondary mirror folded. The tennis court-sized sunshield, made of 5 layers of microscopic Kapton material, folded and compressed down into the size of a delivery van. On December 25, 2021, this 6,500 kilogram time machine was shoved into the nose cone of an Ariane 5 rocket in South America and blasted off the planet. The launch was flawless, but the true terror had only just begun. Unlike Hubble, which orbits just a few hundred miles above Earth, the James Webb Space Telescope was headed for a gravitational parking spot known as the Second Lagrange Point, or L2, nearly 1 million miles away. At that distance, no astronaut could ever reach it. There would be no rescue missions. If a single cable snapped, if a single motor jammed, if a single latch failed to release, the $10 billion mission would become nothing more than high-tech space junk drifting aimlessly in the void forever. During its month-long journey to L2, the telescope had to perform an elaborate mechanical ballet. It had to unfold itself piece by piece in the freezing vacuum of space. Engineers had calculated exactly 340 single points of failure, 340 distinct moments where a single mechanical glitch would end the mission permanently. For weeks, the entire global scientific community held its breath. They watched as the sunshield tensioned perfectly. They watched as the secondary mirror locked into place. They watched as the golden wings swung out and latched seamlessly. Not a single thing snapped. Every single one of those 340 failure points held. The time machine had survived, but survival was only the prerequisite. To detect the impossibly faint infrared glow of the first galaxies, the telescope had to freeze. Any heat radiating from the telescope itself would blind its own sensors. So the 5-layer sun shield blocked the brutal radiation of the sun, cooling the instruments down to nearly 230 degrees below 0 Celsius, just barely above absolute zero. In the silent freezing dark of L2, the 18 golden segments aligned to a precision finer than the wavelength of the light they were catching. The time machine was finally ready to listen to a part of the universe no one had ever heard from before. On July 11, 2022, the first real proof of its power was revealed. It was a single image of a galaxy cluster sitting roughly 5 billion light-years away, known as SMACS 0723. But the cluster itself was not the main target. Its enormous mass was acting as a gravitational lens, warping and magnifying the much older, much fainter light of galaxies sitting far behind it in the extreme distance. The image covered a patch of sky no larger than a grain of sand held at arm's length. Yet inside that tiny grain of sand were thousands of galaxies. Where Hubble had only seen faint structureless smudges, Webb revealed breathtaking details. Spiral arms, blazing galactic cores, and the glowing red signatures of ancient stellar populations. It was not just a better photograph, it was a fundamentally different kind of seeing. Yet buried in the background of this magnificent first image was a terrifying anomaly. A handful of those distant red galaxies did not match the established models of physics. They were too bright, too structured, and entirely too massive for the era of time they were supposed to exist in. The scientists stared at the data, trying to rationalize it, trying to find the error in the calibration. But there was no error. Webb was working perfectly. The universe, however, was not behaving. These early glimpses were just the first drops of rain before a catastrophic storm that would drown decades of cosmological theory. The models were breaking and the real surveys had not even begun. I always thought that launching a telescope 1,000,000 miles into space and hoping 340 fragile mechanisms worked perfectly was the most terrifying part of this mission. But the reality is far more chilling. The true terror is not what could have gone wrong with the machine, but what the machine actually found when everything went right. Next week, we are going to dive into the cosmic fog and the epoch of Ryanization, where Webb uncovered structures so impossibly massive they are being called universe breakers. You absolutely do not want to miss this revelation. Make sure you hit that subscribe button right now, because the history of our existence is about to be rewritten. You might look up at the night sky and imagine space as a crystal clear, endless vacuum, a transparent window stretching out into infinity. But that transparency is a modern luxury. For a significant portion of its early history, the universe was not a clear window at all. Earth and every telescope we ever built prior to this moment has been effectively blinded by a primordial curtain. The early cosmos was choked by an unimaginably dense cosmic fog that swallowed light whole. This was a dark age, a time when the universe was fundamentally opaque, and it remained that way until the James Webb Space Telescope finally found a way to pierce the veil and reveal the staggering structures hiding on the other side. To comprehend the sheer scale of this discovery, we have to travel back to the aftermath of the Big Bang. In its infancy, the universe was a boiling cauldron of plasma. As it expanded and cooled, protons and electrons finally slowed down enough to combine, forming the very first atoms of neutral hydrogen. This event, which occurred roughly 380,000 years after the universe began, plunged creation into absolute darkness. There were no stars yet. There were no galaxies. There was only a vast expanding ocean of neutral hydrogen gas swirling in the pitch-black void. If you were somehow standing in the universe during this epoch and you held a flashlight out in front of you, its beam would not travel far. The neutral hydrogen absorbed and scattered light almost instantly. The cosmos was a thick, impenetrable wall of fog. Astronomers call this long silent period the cosmic dark ages. It was a time of pure potential waiting for a spark. Eventually, gravity began to pull the densest pockets of hydrogen together. These pockets grew heavier and hotter until the pressure at their cores became so intense that nuclear fusion ignited. The first stars violently burst into existence. These were not like the stars we see today. They were monstrous giants burning incredibly hot and emitting fierce ultraviolet radiation. As more and more of these colossal stars ignited and grouped together into the very first primitive galaxies, their intense radiation began to bombard the surrounding hydrogen fog. This process is known as the epoch of ionization. The ultraviolet light systematically ripped the electrons away from the hydrogen protons, effectively burning away the fog and clearing a path for light to finally travel uninterrupted through space. Over hundreds of millions of years, the universe transitioned from completely opaque to the transparent vacuum we recognize today. This transition is the exact period the James Webb Space Telescope was explicitly designed to look back and witness in real time. But witnessing an event that happened billions of years ago requires overcoming an insurmountable obstacle, one that defeated every instrument humanity built before. The obstacle is the expanding fabric of the universe itself. When those ancient stars burned away the cosmic fog, the light they emitted was primarily high-energy, ultraviolet, and visible light. Under normal circumstances, this light should shine brightly through a powerful telescope. But space is not static. From the moment the Big Bang occurred, the universe has been expanding in every direction. And as light travels across the cosmos to reach our eyes, the very space it is traveling through is stretching. This creates a phenomenon astronomers call redshift. Imagine drawing a wavy line on a rubber band and then pulling both ends of the band. The waves stretch out, becoming longer and wider. The exact same thing happens to a photon of light as it journeys across an expanding universe. A photon that left the first galaxies as a tight, energetic wave of visible light gets stretched as it crosses billions of light years of expanding space. By the time it finally arrives at Earth 13 billion years later, its wavelength has been stretched so drastically that it has fallen completely off the visible spectrum. It shifts from blue to red and then pushes deep down into the infrared. This is why the cosmic dark ages and the first galaxies remained invisible for so long. For most of the history of astronomy, that ancient light was washing right over us, hitting our telescopes and our eyes, but we simply could not register it because we were looking in the wrong spectrum. The light was hiding in plain sight, disguised as invisible heat. James Webb changed everything because it was built almost entirely to see infrared wavelengths. It was engineered to capture the ghosts of photons that have been exhausted by a 13 billion year journey across an expanding reality. When Webb captured its first deep field images, it utilized gravitational lensing using the massive gravity of closer galaxy clusters to magnify the incredibly faint, red-shifted light from the edge of time. The results were nothing short of breathtaking. What emerged from the data was not just a handful of glowing embers. The telescope revealed massive complex structures swirling behind the gravitational lenses. We saw spiral arms, we saw vibrant galactic cores, and we saw distinct populations of stars glowing faintly red in the deep infrared. These were structures that had never been recorded by any instrument in human history. Think about the profound nature of what is happening in those images. The light hitting Webb's golden mirrors took 13 billion years to arrive. The structures you are looking at do not exist like that anymore. The stars in those images burned out and died eons before our own solar system was even a cloud of dust. We are essentially watching ghosts dance in a cosmic graveyard. The light has been stretched, transformed, and delivered to us as a message from an era we were never meant to see. I truly thought that the concept of an impenetrable cosmic fog masking the dawn of time was the most mind-bending thing I would ever learn about our universe. But the truth is, the fog was just a cover for something much more terrifying. What Webb actually found hiding inside that clear darkness was not a gentle beginning. Next week, we are going to expose the universe breakers, the galaxies that are so impossibly massive they threaten to destroy the foundation of modern physics itself. You absolutely do not want to miss this reality-shattering revelation, so make sure you hit that subscribe button right now before the algorithm hides this truth from you forever. We are taught that the universe has unbreakable rules. Gravity builds things slowly. Stars form over millions of years. Galaxies take billions of years to assemble their majestic spiral arms and gather their immense stellar populations. But what if those fundamental rules are entirely wrong? The scientists analyzing the first waves of data from the James Webb Space Telescope found something that was explicitly forbidden by every established model of modern physics. They found colossal monsters lurking in the cosmic dawn. They discovered galaxies heavier, denser, and more complex than our own Milky Way, but existing at a time when the universe was barely out of its infancy. These objects are not just statistical anomalies or minor errors in calculation. They are completely destroying our fundamental understanding of how reality itself was built and forcing us to question everything we thought we knew about the origins of structure in the cosmos. To hunt for these impossible structures, researchers launched the most ambitious and demanding deep space observation program in human history. It was called the James Webb Advanced Deep Extragalactic Survey, or JADES for short. This colossal program specifically targeted regions of the sky that had already been mapped by Hubble over the past 2 decades. Hubble had famously stared at these empty black patches of space for hundreds of orbits, gathering the absolute faintest specks of distant light to create the Hubble Deep Field images. But Webb did not just want to see those faint specks, it wanted to tear them apart and analyze their fundamental physical composition. Webb was equipped with highly advanced spectrographs, which are instruments that do not just take a pretty picture, but physically split the incoming light into its component wavelengths. This extraordinary capability allowed astronomers to measure the exact distance of a galaxy not by estimating its color, but by reading the precise physical stretch of its light waves. They could track exactly how much the universe had expanded and stretched that specific beam of light over billions of years. What they found waiting for them in the dark immediately triggered a wave of panic and disbelief across the global astronomical community. For over 40 years, cosmology has relied on a single foundational framework called the lambda cold dark matter model. This standard model dictates a very slow, patient, and methodical universe. In the beginning, according to the theory, tiny clumps of invisible dark matter exerted a gentle gravitational pull, creating invisible scaffolding across the cosmos. Over hundreds of millions of years, these dark matter halos slowly gathered ambient hydrogen gas from the surrounding void. That gas slowly cooled down, eventually collapsing under its own weight to form the very first fragile massive stars. Those individual stars slowly clustered together into small chaotic dwarf galaxies, which over billions of subsequent years crashed into each other and merged to form massive, beautiful structures like our Milky Way. Building a giant galaxy requires an immense amount of time. It is a slow cosmic construction project that operates from the bottom up, relying on endless collisions and mergers. But in early 2023, the JWST data returned hard, undeniable spectrographic proof of galaxies sitting comfortably between 300 and 450 million years after the Big Bang. At this specific point in time, the universe was less than 3% of its current age. According to the lambda cold dark matter model, these early galaxies should have been small, chaotic, and barely visible clumps of unrefined gas and a few scattered young stars. Instead, the Webb telescope found galaxies blazing with the terrifying light of tens of billions of stars. As more ambitious surveys like Cosmos Webb poured in, analyzing hundreds of thousands of galaxies across the deepest reaches of cosmic time, the pattern only grew stronger and more undeniable. Massive, bright, heavily structured galaxies were appearing at the most extreme distances, roughly 10 times more frequently than any computer simulation, theoretical equation, or physical model allowed. The data was not just challenging the standard model, it was persistently and consistently at war with it. The true existential crisis arrived when a team of researchers from Australia identified 6 specific objects originating from the first 5 to 700 million years of cosmic history. These objects were so inexplicably massive that researchers half-seriously nicknamed them the universe breakers. Each one of these 6 early galaxies contained anywhere between 10 billion and 100 billion solar masses worth of stars. To put that staggering number into perspective, our own Milky Way, which is universally considered a mature, large and heavy galaxy by modern astronomical standards, contains roughly 60 billion solar masses. These 6 ancient objects, formed when the entire universe was just a newborn toddler, were already sitting in the exact same heavyweight class as our modern galaxy. They had somehow achieved billions of years of cosmic evolution and stellar assembly in a mere fraction of that time. How does a galaxy build that much mass that incredibly fast? The mathematics of the problem quickly became a waking nightmare for theoretical physicists. To accumulate that many stars in just a few 100 million years, a developing galaxy would need to convert almost every single available atom of primordial hydrogen gas directly into stars continuously and flawlessly from the exact moment the universe cooled down enough to allow it. It would require a star formation efficiency bordering on 100%. But known physics firmly dictates that such relentless efficiency is fundamentally impossible. When a star ignites, its intense radiation and violent solar winds push the surrounding gas away, shutting down further star formation in its immediate vicinity. When massive stars die, they explode as supernovas, blowing the elemental building blocks of new stars completely out of the galaxy. The universe possesses natural negative feedback loops that constantly hit the brakes on star creation. Yet these universe breakers somehow ignored the brakes entirely. They burned with an unnatural ferocity, building themselves into cosmic titans in a window of time that was mathematically far too brief. The scientific community desperately tried to find a flaw in the data to restore order to the cosmos. Perhaps the light was being misinterpreted. Follow-up observations did in fact reveal that some of the immense light coming from a few of these objects was not purely starlight, but the glowing feeding disks of actively feeding supermassive black holes. But even after physicists mathematically corrected for the intense black hole light and stripped it from the equations, the sheer mass of the remaining stars was still impossibly high. The crisis had shrunk slightly in its margins, but it had not disappeared. The standard model of galaxy formation, the absolute bedrock of modern cosmology, was consistently failing to explain the reality that the telescope was capturing. The universe was clearly building its biggest, most magnificent cities before it even had time to lay down the roads. I honestly thought that finding fully formed galaxies heavier than the Milky Way at the dawn of time was the most terrifying physics-breaking discovery we could possibly make. But I was so completely wrong. Finding massive galaxies is one thing, but finding what specific elements are hiding inside them changes the story entirely. Next week we are going to look at the oxygen anomaly, a discovery that proves entire generations of massive stars had already lived and died before we thought the first one had even switched on. This next revelation is where the timeline of existence completely falls apart and the universe reveals its true chaotic nature. You absolutely need to be here for this, so hit that subscribe button right now because the rabbit hole only gets deeper and more dangerous from here. Oxygen is the breath of life. It is the invisible force that fuels our bodies, fills our oceans and sustains the fragile biosphere of our planet. We take it for granted, but in the grand cosmic narrative, oxygen is a rare and highly advanced commodity. So when astronomers pointed the James Webb Space Telescope at the absolute farthest edge of the observable universe and detected the undeniable chemical signature of oxygen, it sent shockwaves through the scientific world. Finding oxygen at the dawn of time is not just a chemical anomaly. It is like opening an untouched ancient Egyptian tomb and finding a fully functioning modern smartphone resting inside the sarcophagus. It is an artifact from the future somehow buried in the deep past. It defies every logical timeline we have ever constructed. The story of this impossible discovery began in May of 2024. A team of international researchers finally confirmed the existence of the most distant galaxy ever directly measured by humanity. They catalogued it under the cold numerical designation JADESGSZ14, but there is nothing cold about this object. The light from this galaxy began its journey toward Earth a mere 290 million years after the Big Bang. At that specific moment, the entire universe was essentially a newborn, just 2% of its current age. You might expect the most distant galaxy ever found to be a tiny, pathetic smudge of faint light struggling to survive in the dark. But JWST-14 was a sprawling luminous titan. It stretched over 1,600 light-years across and contained hundreds of millions of solar masses worth of fully formed burning stars. It was so impossibly bright that researchers noted they could have easily detected it even if it had been 10 times fainter. This implied a terrifying truth. Objects just as large or perhaps even larger might be sitting even further back in time, completely rewriting the opening chapters of reality. But the sheer size of the galaxy was just the prelude to the true crisis. In March of 2025, astronomers followed up on this monstrous galaxy by combining the infrared power of James Webb with the Atacama Large Millimeter Array, a massive network of high-precision radio telescopes perched high in the mountains of Chile. They peered deep into the glowing heart of this ancient structure, looking for the specific spectral lines that reveal chemical composition. And they're hidden in the light from 290 million years after the beginning of everything. They found oxygen. To understand why this discovery is so catastrophic for modern physics, you have to understand where oxygen actually comes from. The Big Bang was a furnace of unimaginable heat and pure explosive expansion, but chemically speaking, it was incredibly boring. The primordial explosion produced almost nothing but raw hydrogen, a little bit of helium, and trace amounts of lithium. There was absolutely no oxygen in the early universe. Every single atom of oxygen in your lungs, in the water you drink, and in the cosmos at large is not primordial. It is a manufactured element. It is forged exclusively inside the crushing high-pressure, high-temperature cores of the most massive stars in the universe. Oxygen is the byproduct of intense stellar nuclear fusion, but simply manufacturing the oxygen inside the core of a star is not enough for a telescope to detect it floating freely in a distant galaxy. The star has to release it. And a massive star only releases its heavy elements when it reaches the absolute end of its lifespan. It must exhaust its nuclear fuel collapse inward under its own immense gravity and detonate in one of the most violent events in nature, a cataclysmic supernova explosion. The shock wave of this explosion rips the star apart and scatters the freshly forged oxygen out into the surrounding interstellar gas clouds. Therefore, detecting oxygen in space is absolute undeniable proof of death. It is the cosmic ash left behind by a massive star that has already perished. This brings us to the timeline paradox that is currently breaking the minds of cosmologists everywhere. To detect a massive cloud of oxygen glowing in a galaxy just 290 million years after the Big Bang means an entire sequence of monumental cosmic events had to occur in an impossibly tight window of time. First, the primordial hydrogen gas had to cool down and condense. Second, the very first generation of massive stars had to ignite out of the darkness. Third, those stars had to burn completely through their entire nuclear lifespans. Fourth, they had to die in violent supernova explosions, perfectly seeding the surrounding void with heavy elements. And finally, a completely new second generation of stars had to gather that enriched gas collapse and ignite to illuminate the oxygen so that our telescopes could see it. According to every model of physics that existed before James Webb launched, that narrow window of 290 million years was barely enough time for the universe to cool down enough to let the very first primordial stars switch on. It was supposed to be a quiet, slow awakening. There was absolutely no mathematical room in the timeline for an entire generation of massive stars to be born, to live, to die, and to seed a whole new cosmic era behind them. The lead researcher on the project called the discovery completely unanticipated, but in reality it is a profound chronological impossibility. This single chemical signature proves that the early universe was operating at a terrifying hyper-efficient speed. The cosmic clock was ticking faster than any equation on our books can currently explain. The universe was rushing to build, rushing to burn, and rushing to die with a violent intensity that makes our modern cosmos look like a slow-moving graveyard. Something in the early universe was forcing matter to evolve at a breakneck pace, and we still have no idea what that driving force could possibly be. I truly believe that discovering entire generations of stars living and dying in the blink of a cosmic eye was the most extreme and violent phenomenon we could ever witness in the deep universe. But the frantic burning of ancient stars is merely a distraction. At the dead center of nearly every one of these impossible early galaxies, something else was growing. Something far darker, far hungrier, and far faster than the laws of physics should have ever allowed. Next week, we are plunging directly into the supermassive crisis, where we will uncover black holes that are literally eating the timeline of the universe alive. You absolutely will not want to miss the monsters lurking in the dark, so hit that subscribe button right now before it is too late. The nightmare was never truly about the stars. Stars are bright. Stars are predictable. Stars operate on thermodynamic principles that we can observe and measure with relative comfort. But at the dead center of nearly every one of these impossible early galaxies, something else was waiting for us. Monsters were lurking in the absolute dark, swallowing everything around them with a speed that blatantly violates the fundamental physical speed limits of the cosmos. As the James Webb Space Telescope peered deeper into the primordial early universe, it did not just find oversized bloated galaxies. It found the supermassive engines powering them, and these violent gravitational engines were growing at a rate that is mathematically and physically impossible. The supermassive crisis had officially begun. To truly understand the sheer scale of this new crisis, we must first look back at our own relatively calm cosmic backyard. At the dead center of nearly every large mature galaxy in the modern universe sits a supermassive black hole. Our own Milky Way galaxy harbors one called Sagittarius, a star. It is a terrifying invisible beast, carrying roughly 4 million times the mass of our Sun, condensed into an infinitesimally small point. But today, in our current cosmological era, Sagittarius A star is remarkably quiet. It is largely dormant. It feeds entirely on scraps, an occasional drifting cloud of ambient interstellar gas, or a rare unfortunate star that wanders too close to its event horizon might fall in, but otherwise it is a sleeping giant resting peacefully at the center of an orderly spinning galaxy. Astronomers have studied these modern black holes for decades, and they built a very solid, robust theoretical model of how they grow over time. It is a process that requires extreme patience and immense stretches of cosmic history. A standard black hole begins its life very small. It usually forms from the violently collapsed core of a single massive dying star, a stellar mass black hole. This tiny gravitational seed must then slowly, meticulously eat its way up to millions or even billions of solar masses over billions of years of cosmic history. And there is a strict absolute physical speed limit on exactly how fast it is allowed to eat. This speed limit is a fundamental law of astrophysics known as the Eddington limit. When a black hole exerts its extreme gravity and pulls in surrounding gas, that material does not just fall straight in. It swirls around the event horizon, flattening into a violently hot, chaotic accretion disk. As the gas molecules rub together at significant fractions of the speed of light, they generate unimaginable friction. This friction heats the plasma to millions of degrees, causing it to emit blinding intense radiation across multiple wavelengths. The Eddington limit describes the exact mathematical point where the outward pressure of this brilliant intense radiation becomes so incredibly powerful that it literally pushes the remaining incoming fuel supply away. If a black hole tries to eat too aggressively, the blinding light it generates acts as a physical shield, blowing its own food into deep space. Therefore, even if a black hole is feeding continuously at its absolute maximum sustainable Eddington limit, without a single second of interruption, growing a small stellar seed into a supermassive titan takes hundreds of millions or even billions of years. It requires perfectly stable feeding conditions for an absolute eternity. Think of it like trying to fill an enormous Olympic-sized swimming pool using a tiny plastic drinking straw. The straw can only handle a very small specific amount of water at any given time. If you become impatient and try to force a high-pressure fire hose through that tiny straw, the straw will simply burst and the water will scatter everywhere. No matter how impatient you are or how much water you have available, there is a rigid physical ceiling on exactly how fast that giant pool can be filled. Under the standard accepted model of modern physics, the early universe simply had not existed long enough to hit that ceiling. There was nowhere near enough time on the cosmic clock for the pool to be full. But the James Webb Space Telescope completely ignored the cosmic clock. It looked out into the dawn of time and it kept finding massive swimming pools that were already overflowing with water at the very beginning of creation. In 2024, a dedicated team of researchers at Cambridge University confirmed a supermassive black hole sitting at the dark center of a galaxy, roughly 400 million years after the Big Bang. This black hole was already carrying about 1.6 million solar masses. It was actively pulling in roughly one entire star's worth of material every 5 years. That might sound like a steady diet, but to reach 1.6 million solar masses in that incredibly short window of cosmic time, it would have needed to bypass the strict Eddington limit entirely. It would have had to consume matter at a rate that physics simply forbids. The crisis deepened even further shortly after, when astronomers combined the deep infrared sight of the James Webb Space Telescope with the piercing X-ray vision of the Chandra X-ray Observatory. Working together, these two great observatories found an even larger monster lurking in the ancient dark. They discovered a supermassive black hole weighing anywhere between 10 million and 100 million solar masses at an even earlier point in the timeline, sitting just 450 million years after the Big Bang. Less time to grow but carrying significantly more mass. The mathematics simply kept getting harder and harder to justify. How do you build a 100 million solar mass black hole in a universe that is just waking up from the dark ages? The Eddington limit is not just a casual suggestion. It is the delicate critical balance between gravity pulling matter inward and radiation pushing matter outward. If these early ancient black holes were genuinely feeding faster than the limit allows, they should have generated enough intense blinding radiation to completely sterilize their host galaxies. That radiation should have acted like a cosmic bomb, blasting away all the surrounding gas and instantly shutting down any new star formation across the entire galaxy. Yet these exact same early galaxies show clear, undeniable evidence of massive frantic star formation happening right next to a supermassive engine that should be systematically destroying the very environmental conditions that allow stars to exist. It is a catastrophic cosmological paradox. We are looking directly at ancient objects that demand entirely conflicting realms of physics to operate. They are actively eating their host galaxies alive, while simultaneously allowing them to bloom with millions of new stars. Theoretical cosmologists are currently scrambling for answers in the dark. Perhaps these early black holes did not actually start as the tiny cores of dying stars. Perhaps there is an unknown exotic mechanism that allows them to bypass the strict laws of radiation pressure entirely. Or perhaps our entire fundamental understanding of how gravity operates and scales in the extreme density of the early universe is just fundamentally flawed. Webb did not just take beautiful infrared pictures of early supermassive black holes. It took high-resolution pictures of a cosmological crime scene, and all the undeniable evidence points to a massive failure in our standard theoretical physics. The universe was clearly not built slowly and patiently. It was forged in a violent, chaotic rush of extreme gravity that we are only now just beginning to comprehend. I always thought that finding these impossibly large, ravenous supermassive black holes at the absolute edge of time was the most terrifying realization we could ever have. To know that the universe gave birth to its biggest absolute destroyers before it even finished building its first majestic cities is deeply unsettling. But as scientists kept analyzing the infrared data, they found a specific newly discovered class of objects that made these giant, supermassive black holes look incredibly normal. Next week, we are going to expose the little red dots. These are objects that are so profoundly unnatural and unsettling, they feature black holes that actually outweigh the entire massive galaxy that is supposedly trying to host them. It is a gravitational nightmare that completely flips the hierarchy of the cosmos on its head, and you absolutely do not want to miss it. Make sure you hit that subscribe button right now, because the early universe is about to show us its true primeval monsters. They are called little red dots. It sounds so completely harmless, almost cute. You might imagine tiny specks of distant starlight struggling to shine through the immense darkness of the early cosmos. But in the world of astrophysics, a cute nickname is often used to mask something deeply unsettling. Until you realize the true scale of what these little red dots actually are, you cannot grasp the panic they have caused. These tiny reddish anomalies represent supermassive black holes that completely outweigh the entire planetary systems and galaxies that are supposedly hosting them. They are gravitational monsters that have completely hijacked their own homes. To understand why these specific objects are currently tearing the cosmological community apart, we have to establish a fundamental rule of galactic architecture. In the present day, modern universe galaxies and the supermassive black holes at their centers share a very strict, very predictable relationship. It is an evolutionary partnership that has held steady across millions of observations. Typically, a galaxy's central supermassive black hole accounts for roughly 1/10 of 1% of the galaxy's total stellar mass. If a galaxy grows larger, its central black hole grows proportionally larger along with it. It is a delicate, balanced cosmic dance. The tail never wags the dog. The engine is never heavier than the car itself. This ratio is so incredibly consistent that astrophysicists routinely use it to estimate the mass of distant, unseen black holes simply by measuring the starlight of the surrounding galaxy. But the early universe, it seems, did not care about our modern rules of architecture. In 2024, a dedicated research team at the Institute of Science and Technology Austria began systematically cataloging a bizarre population of extremely compact reddish objects buried deep in the James Webb Space Telescope data. These objects possessed a very distinct, unmistakable spectral shape that set them entirely apart from anything observed in the nearby local universe. They were sitting at a period roughly 600 million to 1.3 billion years after the Big Bang. The researchers identified exactly 341 of these anomalies. The black holes buried inside these little red dots range anywhere from 1 million to 100 million solar masses. Now, on its own, a 100 million solar mass black hole in the early universe is incredibly difficult to explain, but it is not entirely unprecedented. What made these specific objects a total nightmare for theoretical physics was how much of their host galaxy that incredible mass actually represented. In these little red dots, the ratio between the black hole and the surrounding stars was not 1/10 of 1%. The ratio skyrocketed to 30% or even higher. These black holes were roughly 300 times larger than the standard normal proportion allows. They were not small galaxies hosting modest black holes. They were massive, blindingly bright black holes that nearly outweighed all the stars, gas, and dust of the entire galaxy surrounding them combined. Imagine finding a massive industrial freight train engine sitting inside the chassis of a tiny compact car. It makes absolutely no physical sense. How does a supermassive black hole grow to such catastrophic proportions without a massive galaxy to feed it and nurture it? There are currently 3 competing explanations proposed by theoretical physicists, and frankly, none of them fully close the gap or make the math comfortable. The first explanation involves a purely theoretical mechanism called direct collapse. Under very specific, highly unusual conditions in the extremely dense radiation-filled early universe, a massive cloud of primordial hydrogen gas might theoretically collapse directly inward upon itself. It would bypass the normal star formation phase entirely. Instead of fragmenting into millions of individual stars, the entire gas cloud would crush down into a single point, immediately birthing a black hole already carrying tens of thousands of solar masses. That would certainly give the black hole a massive head start over the surrounding galaxy. But producing direct collapse black holes in the massive numbers needed to explain all 341 catalogued objects stretches the mathematical mechanism well past its comfortable physical limits. The second explanation simply demands that these black holes grew by feeding much faster than the strict Eddington limit allows. While computer simulations show that a black hole can temporarily exceed this speed limit for very short violent bursts, the little red dots would require sustained continuous excess growth over hundreds of millions of years. That is far longer than any simulation has ever successfully produced without breaking down. Furthermore, there is a massive contradiction built directly into this idea. A black hole feeding that aggressively should generate enough blinding radiation to completely blast away all the surrounding gas, shutting down any nearby star formation. Yet these exact objects show clear, undeniable evidence of active star formation happening right next to an engine that should be actively destroying the environment. The third explanation has fewer mainstream supporters, but it is becoming increasingly harder to dismiss outright because of how desperate the situation has become. It involves primordial black holes. These are hypothetical objects that did not form from dying stars at all. Instead, they may have formed directly from extreme microscopic quantum density fluctuations within the very first fraction of a single second after the Big Bang itself. If they actually exist, they would have provided massive ready-made gravitational seeds for galaxy building long before a single star had ever switched on. They would skip the entire slow, tedious climb through stellar collapse and feeding altogether. It is the most radical explanation because it implies the universe was born already heavily seeded with monsters. Whatever the true answer is, the undeniable reality is that the early universe built its most extreme chaotic objects first. It forged its biggest, fastest growing black holes long before it built anything resembling the calmer, more spread out organized cosmos we see around us today. The quiet galactic neighborhood we currently call home, with its dormant sleeping black hole and its slow, orderly spiral arms, is not the universe's natural state at all. It is simply the exhausted, burned-out aftermath of a violent prehistoric war. If you think these isolated gravitational monsters are terrifying, you have not seen anything yet. Because these extreme objects were not just scattered randomly across the void. Zoom out far enough and the universe stops looking like a random scattering of points and starts looking like a deliberately constructed web. Next week, we are going to expose the cosmic web and the horrifying dead zones hiding between its massive glowing threads. We are diving straight into the Bootes void, a region of space so unimaginably empty, it completely breaks human intuition and makes us question our own isolation. You absolutely do not want to miss the true architecture of the universe, so make sure you hit that subscribe button right now before you lose your way in the dark. If you think the supermassive black holes and impossibly massive early galaxies are the most terrifying things in the universe, I need you to completely change your perspective. Those glowing monsters are just the bright spots. If you truly want to understand the profound, deeply unsettling nature of reality, you cannot just look at the light. You have to look at the dark. You have to look at the spaces between the light, because there are regions in the deep cosmos that are so incredibly vast and profoundly empty that they completely break human intuition. They are dead zones so immense that they make astronomers physically shudder. Welcome to the true architecture of the universe and the horrifying reality of the cosmic voids. To comprehend this, we must zoom out far beyond any single black hole and far beyond any single galaxy. When you step back and view the observable universe on the absolute largest scale possible, it stops looking like a random scattering of glowing dots. It starts looking like deliberate biological architecture. Galaxies are not spread evenly through space like dust floating in an empty room. Instead, they clump together and string themselves along massive glowing thread-like structures. These threads intersect at brilliantly dense knots, where thousands of galaxies smash together in massive chaotic clusters. And between these blinding threads lie vast, terrifying stretches of absolute nothingness. Together, this breathtaking overall structure is known as the cosmic web. It is the largest coherent physical structure in existence. This magnificent web exists because the early universe was not perfectly smooth. In the very first fraction of a single second after the Big Bang, there were microscopic quantum variations in density. Over hundreds of millions of years, gravity slowly, patiently amplified those tiny variations. The primary architect of this entire web is not ordinary matter but dark matter. Dark matter is completely invisible and directly undetectable, but its immense gravitational pull forms the unseen massive skeleton of the cosmos. Ordinary luminous matter like galaxies and stars are simply the bright decorations resting on top of this massive invisible dark matter scaffolding. A single glowing filament connecting two dense galaxy clusters can stretch for hundreds of millions of light years and carry more total mass than thousands of individual galaxies combined. And thanks to the piercing infrared eyes of the James Webb Space Telescope, we now know that this massive scaffolding was being constructed far earlier and far faster than the standard cosmological model ever predicted. The universe was weaving its web while it was still suffocating in the primordial fog. But a web is not just made of threads. A web is fundamentally defined by its gaps. As gravity spent billions of years pulling matter inward toward the dense intersecting filaments, it simultaneously emptied out the spaces in between. It created massive expanding bubbles of pure desolation. These are the cosmic voids. Most voids are relatively small on a cosmic scale, just a few tens of millions of light years across, containing scattered rogue galaxies that drifted away from the main gravitational highways. But some of these voids are so unimaginably large that they completely defy our mathematical understanding of how structure forms in a universe that is supposed to be relatively uniform. The absolute most infamous and terrifying of these empty spaces sits in the direction of the constellation Bootes. It was discovered back in 1981 during a routine astronomical survey of galactic distances. Astronomers fully expected to find the usual normal variation in cosmic density. A few clusters here, a few slightly emptier patches there. What they found instead was a roughly spherical region of absolute nothingness stretching an incomprehensible 330 million light-years across. Based on the standard density of the surrounding universe, a region of space that incredibly vast should contain at least 2,000 massive galaxies. Instead, after decades of frantic searching with our most powerful telescopes, astronomers have only managed to find about 60 isolated lonely galaxies drifting aimlessly in the dark. The astronomer who originally discovered this massive anomaly famously stated that he was physically embarrassed to tell his colleagues just how completely empty it was. To truly grasp the sheer horrifying scale of the Bootes void, we have to place ourselves inside of it. Let us perform a thought experiment. Imagine if our own Milky Way galaxy, our solar system, and our little Earth were dropped perfectly into the dead center of the Bootes void. If humanity had evolved in the exact center of that massive expanse of nothingness, our entire history of astronomy would have been completely erased. Because the nearest neighboring galaxies would be so incredibly far away, the primitive optical telescopes of the 19th and early 20th centuries would never have been able to detect them. As far as humanity would have known, the Milky Way was the entire universe. We would have looked out into the deep night sky and seen an absolute endless wall of black. We would not have realized that other galaxies even existed until the advent of highly advanced space telescopes in the late 1960s or 70s. an entire monumental chapter of human understanding. The profound realization that the universe is unimaginably larger than our own isolated island of stars would have been delayed by over half a century. Not because we were not smart enough to figure it out, but simply because of where we happened to be physically standing. That single terrifying fact completely reframes everything we think we know about reality. Your physical address inside the cosmic web does not just dictate what you can see in the night sky. It absolutely dictates what you are physically permitted to know about the universe itself. The laws of physics might be universal, but our human perception of them is hopelessly biased by our specific cosmic geography. The Bootes void is a haunting reminder that space is not uniform, and our view of it is heavily restricted by the silence of the dark. I always thought the Bootes void was just a bizarre, distant anomaly that we could safely observe from afar. A terrifying dead zone that we were incredibly lucky to avoid. But the truly chilling reality is much closer to home. What if I told you that we are not safely resting on the bright glowing threads of the cosmic web at all? Next week, we are going to look in the mirror because compelling astronomical evidence suggests that Earth is currently trapped deep inside a massive dead zone of our own called the KBC void. We are adrift in a cosmic desert, and it is quietly skewing our fundamental math of reality. You absolutely must be here for this terrifying revelation, so hit that subscribe button right now before the void swallows us completely. We have spent centuries building a comforting philosophical foundation called the Copernican principle. It is the fundamental assumption that Earth does not occupy a special privileged or unique physical position in the universe. We are supposed to be ordinary. We are supposed to be sitting in a perfectly average, unremarkable patch of space, looking out at a perfectly average uniform cosmos. But the deeper we map the true architecture of the universe, the more that comforting philosophy shatters. As we just learned, there are terrifying regions of absolute nothingness called voids where the cosmic web has been entirely hollowed out. You might think those dead zones are distant anomalies happening millions of light years away from us. But the bitter chilling truth is that we are not safely resting on a bright glowing thread of the cosmic web. We are currently trapped deep inside a massive dead zone of our own. Humanity is adrift in a cosmic desert, and our isolation is secretly distorting everything we think we know about reality. To uncover our true address in the cosmos, a dedicated team of researchers in 2013 decided to look at the local universe with an entirely new perspective. They were analyzing massive data sets of galaxy distributions, trying to map the exact density of the space immediately surrounding the Milky Way. What they found was so completely contrary to the standard cosmological model that it was initially met with intense skepticism. They discovered that our entire local galactic neighborhood is sitting right in the middle of a colossal underdense region of space. They named it the KBC void after the three astronomers who identified it, Keenan, Barger, and Cowie. But calling it a void almost feels like an understatement. You must understand the sheer scale of this emptiness. The KBC void is roughly 2 billion light-years across. It is completely spherical, and our Milky Way galaxy sits well inside its boundary rather than near the edge. Let that sink in for a moment. 2 billion light-years of empty space. This dead zone is 6 times larger than the diameter of the infamous Bootes void, the exact same Bootes void that was so incredibly empty, its discoverer was embarrassed by it. We are living inside a bubble of nothingness, so unimaginably vast that it dwarfs the most terrifying dead zones we can observe in the deep sky. Inside the boundaries of this massive expanding bubble sits our entire local supercluster. But what exactly is our local supercluster? In 2014, a brilliant team led by a researcher in Hawaii formally mapped our galactic neighborhood for the very first time. They did not just plot the simple positions of the galaxies. They used a massive catalogue of galaxy velocities, tracking not just where galaxies sit right now, but exactly where they are physically headed. By analyzing the motion of thousands of galaxies, they reconstructed the invisible gravitational landscape that dictates their flow. They realized that galaxies in our universe behave exactly like water flowing down a mountain range. Matter naturally flows toward density, drawn along invisible gravitational channels toward massive unseen basins. They named the resulting structure Laniakea, which is a Hawaiian word that beautifully translates to immeasurable heaven. Laniakea spans roughly 500 million light-years across, and it contains more than 100,000 individual galaxies. All 100,000 of these galaxies, our own Milky Way included, are gravitationally bound into a single massive flowing structure. But here is the most unsettling part of this discovery. The entire immeasurable heaven is moving. Every single one of those 100,000 galaxies is slowly flowing inward, drawn through the dark toward a terrifyingly dense concentration of mass located in the direction of the constellation Centaurus. Astronomers gave this mysterious mass a name that sounds like it belongs in a science fiction horror film. They call it the Great Attractor. It is a gravitational anomaly so incredibly massive that it is literally bending the trajectory of everything within a 500 million light-year radius. We cannot even get a clear optical picture of what the Great Attractor actually is because it happens to sit directly behind the zone of avoidance. This is the dense band of cosmic dust and gas running straight through the center of our own Milky Way, which permanently blocks our visible sight lines into that specific region of deep space. We are being relentlessly pulled toward a gravitational monster hiding entirely in our own shadow. And if that is not terrifying enough, modern velocity maps show that beyond the Great Attractor lies something even larger, pulling the Great Attractor itself toward it. It is an ultimate accumulation of mass known as the Shapley concentration, the single densest accumulation of galaxies in our entire local universe. So our cosmic address is completely absurd. We are a tiny galaxy part of a massive flowing river of 100,000 galaxies rushing blindly toward an unseen gravitational attractor, all while being entirely encapsulated inside a 2 billion light-year wide sphere of absolute emptiness. But this is not just a bizarre piece of geographic trivia. Our bizarre location in the universe has a direct catastrophic physical consequence. Because we live inside an underdense void, matter experiences gravity very differently here than it does in a normal average region of the universe. If you are sitting inside a void, the galaxies near the edges of that void tend to get an extra outward push. They are being gravitationally pulled outward toward the denser, heavier walls of matter that surround the void. As the void itself slowly empties further over time, this outward pull accelerates. This means that if human beings are sitting inside this bubble, aiming our telescopes at nearby galaxies, trying to measure how fast the universe is expanding, those nearby galaxies are moving faster than they normally should be. They are riding a localized gravitational wave, pulling them toward the void walls. Our position inside this massive bubble is quietly inflating the velocities of everything around us. Therefore, any measurement of cosmic expansion taken from inside this void is going to read significantly higher than the true global rate of the entire universe. It is not because our multi-billion-dollar telescopes are broken. It is not because the scientists are doing the math incorrectly. It is simply because we are measuring reality from inside a distorted bubble, and the bubble is quietly lying to us. Our address in the universe is not a neutral mathematical fact. It is a physical circumstance with measurable, devastating consequences for the numbers our most precise instruments hand back to us. We are looking out through a warped lens of empty space, and it has created the single greatest crisis in the history of modern physics. I always thought that being dragged blindly toward an invisible great attractor was the most helpless, terrifying position humanity could possibly be in. But the motion of our galaxy is nothing compared to the war currently raging over the fundamental speed of the cosmos. Our isolation inside the KBC void has inadvertently triggered a mathematical civil war that is tearing the scientific community in two. Next week, we are plunging directly into the Hubble tension. Two teams of the smartest people on Earth, using the most advanced machines ever built, have arrived at two completely different numbers for the expansion of the universe. One of them has to be wrong, or physics itself is broken. You absolutely do not want to miss the resolution of this crisis, so hit that subscribe button right now before the universe expands beyond our reach forever. For over a decade, two teams of the most brilliant scientists on the planet have been locked in a bitter mathematical civil war over a single number. It is arguably the most important number in all of cosmology, the precise rate at which the universe is actively expanding. The James Webb Space Telescope was explicitly deployed into the freezing darkness to settle this war once and for all. It was supposed to look at the math point out the human error and bring peace back to the divided physics community. But it did exactly the opposite. It looked at the warring factions and declared that both teams were absolutely correct, and therefore the fundamental laws of physics themselves are broken. Welcome to the Hubble tension, the deepest, most terrifying crack in the foundation of modern science. To understand why astrophysicists are losing sleep over a single number, you have to go back to the year 1998. That was the year astronomers made a cataclysmic discovery. The expansion of the universe was not slowing down as gravity dictated it should. It was actively, violently speeding up. This runaway acceleration introduced a dark, dominant, repulsive force into the cosmos that we now simply call dark energy. Ever since that Nobel Prize-winning discovery, pinning down the exact speed of this expansion has been the holy grail of observational cosmology, because that single number underpins absolutely everything else. It dictates the true age of the universe. It dictates the vast distances to the ancient galaxies Webb has been photographing. It dictates the timeline of those impossible overgrown black holes. It is the master key to reality. But when we tried to measure it, the universe gave us two completely different answers, depending entirely on which direction we decided to look. The first method of measuring this master number looks backward into the absolute deepest past. It examines the cosmic microwave background, which is the frozen fossilized afterglow of the Big Bang itself. By meticulously analyzing the microscopic temperature fluctuations locked inside this ancient light, from when the universe was just 380,000 years old, scientists can run our standard cosmological models forward. They can predict exactly how fast the universe should be expanding today, based on its initial starting conditions. This method represents the ultimate standard model of physics, working exactly as intended. And it consistently hands back a very specific, very confident number, 67 kilometers per second for every additional megaparsec of distance. It is a precise, elegant, perfectly calculated answer, rooted securely in the dawn of creation. The second method works in the exact opposite direction. Instead of looking at the beginning of time, it starts right here in our local cosmic backyard, and physically builds a measuring stick outward into the dark. Astronomers call this the cosmic distance ladder. They begin by looking at nearby pulsating stars called Cepheid variables. These are specific, magnificent stars that throb with a rhythmic blinking brightness that allows us to calculate their exact physical distance from Earth. Then the astronomers climb the ladder upward to neighboring galaxies, using those Cepheid variables to calibrate the blinding, catastrophic light of exploding supernovas. By tracking these supernovas as they drift away from us, they can measure the current localized expansion rate of the universe directly. This method is not theoretical, it is raw observational reality, and it consistently hands back a completely different number, 73 kilometers per second per megaparsec. 67 versus 73 might not sound like a catastrophic, unbridgeable gap to a casual observer, but both of these numbers come with remarkably tight error bars. In the ultra-precise, rigorous realm of astrophysics, this disagreement is known as a 5-standard deviation discrepancy. To put that level of statistical confidence into perspective in the world of particle physics, a 5 sigma result is the absolute standard threshold required before a brand new fundamental discovery is officially announced to the entire world. The Hubble tension cleared that massive statistical bar years ago. The gap has only become more precise, more rigid and more undeniable with every single new data set added over the last decade. In physics, a 5 sigma gap means you have not just made a simple measurement mistake. It means you have collided with a brand new unknown law of nature, or it means your entire fundamental model of reality is fatally flawed. For years, the scientific community comforted themselves with a very simple, very human assumption. They assumed that better instruments would eventually make this terrifying gap close on its own. They assumed the older Hubble Space Telescope simply had blurry vision and was perhaps misreading the distances to those local pulsating Cepheid stars due to cosmic dust or crowded galactic starlight. They waited patiently for the James Webb Space Telescope to launch so its flawless, unblinking infrared eyes could re-examine those exact same stars, check the math, and prove that the local measurement was just a minor instrumental error all along. When James Webb finally released its distance measurements in 2023, the entire global cosmological community held its collective breath. Webb stared deep at the exact same stars Hubble did. Its vision was perfect, its instruments were flawless, and it confirmed beyond a shadow of a doubt that Hubble was right all along. The local measurement of 73 was absolutely correct. The instrumental error excuse, one of the most comforting and plausible explanations on the table, had just been effectively brutally ruled out by the most precise telescope ever built by human hands. The crisis is completely real. The early universe and the modern universe are fundamentally operating at two entirely different speeds, and neither measurement is wrong in any simple fixable sense. It means there is an unaccounted variable, a dark phantom mechanism operating in the background of reality that is altering the fabric of space over time. We thought we had a complete blueprint for how the cosmos operates, but the blueprint is missing a massive structural pillar. I always thought that two massive teams of genius physicists fighting over a decimal point was just an academic dispute, a tedious math problem waiting to be patiently solved in a laboratory. But this is not a simple math problem. It is a terrifying message from the universe itself. The laws of physics are not constant, and if the fundamental speed of expansion is broken, it means the dark energy driving that expansion might be actively changing its nature. Next week, we are facing the ultimate nightmare. We are looking at the three physical endings of the cosmos. We will explore how dark energy is preparing to tear apart the very atoms of our bodies in the Big Rip. You absolutely do not want to miss the end of everything, so hit that subscribe button right now before the cosmic clock permanently runs out. We have spent the last century believing in a ghost. When astronomers originally discovered that the expansion of the universe was mysteriously accelerating, they desperately needed a mathematical placeholder to explain the invisible repulsive force that was actively pushing everything apart. They called it dark energy. For decades, the absolute foundational bedrock of modern theoretical cosmology has rested on one very simple, very comforting assumption about this invisible ghost. We assumed it was a cosmological constant, a fixed, permanent, unyielding feature of empty space itself. We fundamentally believed that no matter how far the universe expanded, this dark energy would maintain exactly the same density, pushing outward with exactly the same unrelenting force forever. It was supposed to be the one true, unchanging variable in a universe defined by chaos and violent evolution. But the James Webb Space Telescope, combined with its companion observatories on Earth, has just shattered that final comforting illusion. The ghost is not constant. It is actively mutating, and its current mutation is deciding the exact terrifying method by which our entire universe will eventually die. In April of 2024, a colossal spectroscopic survey instrument mounted on a telescope high in the mountains of Arizona released a completely unprecedented map of the cosmos. Over its first massive year of operation, it had meticulously tracked the red shifts of more than 6 million individual galaxies, building the absolute largest, highest resolution, three-dimensional map of the universe's large-scale structure ever attempted by humanity. When theoretical physicists combined this massive new structural map with the ultra-precise early universe data from the James Webb Space Telescope, they noticed something horrifying buried deep in the mathematics. The timeline of dark energy was not a flat horizontal line. The raw data showed a massive undeniable deviation from the standard cosmological constant model. It appeared that over the last few billion years of recent cosmic history, dark energy had actually weakened by roughly 10%. The repulsive force that makes up nearly 70% of all the mass and energy in the known universe, the absolute dominant dictator of physical reality, is slowly, mysteriously losing its grip. This single staggering revelation changes absolutely everything, because the long-term behavior of dark energy is the only variable that actually matters when it comes to the end of time. Physicists measure the exact behavior of dark energy using a very specific mathematical parameter that directly compares its physical pressure to its physical density. For a true eternal cosmological constant, that specific parameter must sit exactly at -1 forever without fluctuating. But the newest analytical data heavily suggests that dark energy has been wildly fluctuating across cosmic epochs. It appears to have briefly crossed that sacred mathematical line in the deep past, acting temporarily as something physicists call phantom energy, before crossing back over the threshold and steadily weakening ever since. Phantom energy is a theoretical mathematical nightmare. It is a repulsive force that actually grows exponentially stronger the more the universe expands, creating a catastrophic infinite feedback loop with absolutely no natural ceiling. The terrifying fact that our universe has demonstrated the physical capacity to cross into phantom energy territory means that the ultimate fate of everything is no longer a settled scientific debate. We are now staring straight down the barrel of three completely different, absolute apocalyptic conclusions. The first potential ending is the one we have calmly accepted for the last 20 years. It is classically known as the heat death or the big freeze. If dark energy stabilizes or simply weakens incredibly slowly over time, the universe will just continue to expand outward, forever growing endlessly colder and endlessly emptier. It is a slow, quiet, agonizing death by isolation. Over trillions of years, the beautiful galaxies currently glowing in our night sky will be pushed so incredibly far away from us that their light will physically never be able to cross the expanding void to reach us again. The night sky will go completely pitch black. The remaining stars will slowly exhaust their nuclear fuel and burn out one by one like dying embers in a freezing fire. Supermassive black holes will eventually dominate the dark, but even they will slowly evaporate into absolute nothingness through the creeping process of Hawking radiation. Eventually, the entire universe will reach a state of absolute maximum entropy, where no thermodynamic energy can ever be exchanged, and literally nothing will ever happen again for all of eternity. It is an ending of ultimate permanent silence. But if the dark energy mutates again and crosses permanently back into phantom energy territory, we face the second, far more violent ending, the Big Rip. This is a catastrophic unraveling of physical reality itself. In this scenario, the repulsive force of dark energy keeps strengthening without any natural limit. It becomes so overwhelmingly powerful that it begins to actively overpower the four fundamental forces of nature one by one. First, it overpowers the immense gravity, holding massive galaxy clusters together, scattering them completely into the void. Then it overpowers the gravity holding individual galaxies together, violently ripping the spiral arms away from their central supermassive black holes. A few months before the absolute end, it overpowers the localized gravity of individual solar systems, flinging helpless planets away from their host stars into the freezing dark. In the final fraction of a single second before the end of time, dark energy becomes stronger than the electromagnetic and strong nuclear forces. It literally rips the physical atoms of your body apart, tearing protons and neutrons into fundamental quantum shreds. Reality physically shreds itself into absolute nothingness. The third ending is the most ancient fear of all, recently revived by a controversial 2025 theoretical physics paper. What if the current outward push of dark energy is not a permanent destination at all, but merely a temporary localized phase? If dark energy continues to severely weaken over the next 11 billion years, gravity, the oldest and most patient force in the cosmos, will eventually regain the upper hand. The runaway expansion of the universe will suddenly screech to a halt, and then agonizingly slowly at first, everything will begin to fall back inward. This is the big crunch. The night sky will not darken. It will grow blindingly bright as hundreds of billions of galaxies rush back toward each other, colliding and merging in an unimaginable cosmic furnace. The ambient temperature of the background universe will skyrocket, boiling away the atmospheres of any remaining planets. Eventually, all the matter, all the light, all the surviving black holes, and all the physical space of the entire observable universe will crash back down together into a single infinitely dense microscopic singularity. A total violent collapse back into the exact same fiery infinitesimal point from which we were originally born. Three absolute physical endings: a freezing eternal silence, a violent atomic shredding, or a crushing fiery collapse. And the most terrifying part of this entire cosmological journey is that the exact same James Webb Space Telescope that found the impossible ancient galaxies, the supermassive black hole anomalies, and the giant cosmic voids has just told us that the current available mathematical evidence cannot definitively rule out any of these three apocalyptic scenarios. We simply do not know how our story ends anymore. But there is a profound, dark, beautiful poetry hiding inside this immense uncertainty. We happen to exist right now in this exact specific microscopic sliver of cosmic time, where the universe is still perfectly legible. We are alive in the exact biological window where the oldest ancient light is still detectable, where the galaxies are still close enough to be spectacularly photographed, and where the grand architecture of reality can still be measured and mathematically debated. Trillions of years from now, any hypothetical intelligence that evolves in the dying dark will look up at a completely empty black sky. They will have absolutely no physical evidence that the Big Bang ever happened. They will never know about the magnificent cosmic web, the ancient universe breakers, or the beautiful spiral galaxies that once illuminated the primordial void. The physical evidence of creation will be permanently erased by the relentless expansion of space. We are the lucky ones. We are the universe actively experiencing its own magnificent, terrifying prime. But our journey into the dark is far from over. The universe is actively changing its fundamental rules as we speak, and the cosmic clock is relentlessly ticking. In our next video, we are going to dive exclusively into the exact step-by-step timeline of the Big Rip scenario. We are going to mathematically simulate the exact day the sky tears itself apart and explore what a highly advanced humanity could possibly do to survive the death of atoms. You absolutely do not want to miss the end of reality itself. Hit that subscribe button right now because the cosmos is a violently changing place and you need to be prepared for exactly what comes next. We are currently living in the stelliferous era, the era of starlight. It is a time of violent, rapid starbursts, of colossal supernovas, and of sprawling, vibrant spiral arms painting the cosmos in ultraviolet and infrared. Galaxies like our own Milky Way are teeming with energetic processes, producing heavy elements and bathing countless worlds in warmth. But this brilliance is a temporary chemical illusion. The universe is running on a strictly finite tank of fuel. The vast interstellar clouds of primordial hydrogen gas, the very nebular nurseries that give birth to stellar giants, are not infinite. Every star that ignites, every solar system that coalesces from the dust, irreversibly consumes a fraction of the cosmos' precious reserve of raw material. Fast forward roughly 100 trillion years from now. The frantic era of star formation has ground to a complete and permanent halt. The last remaining clouds of hydrogen have been exhausted, either fused into heavier elements, trapped in the cores of dead stars, or scattered thinly into the expanding intergalactic void. The night sky, once ablaze with the familiar majestic spiral arms of galaxies, will undergo a profound shift. The spirals will slowly dissolve. The grand sweeping structures of the cosmic web, tied together by dark matter and illuminated by young blue stars, will begin to fade into memory. The universe will transition out of the vibrant stelliferous era and cross the threshold into the dark freezing expanse of the degenerate era. You might assume that when the great galaxies fade, the universe simply goes dark in an instant, but the actual survivors of this cosmic twilight are strange, tenacious entities that will outlive everything we know by trillions of years. As the massive, brilliant stars die off in glorious supernova explosions, leaving behind black holes and neutron stars who inherits the cosmos. The survivors are not the brightest, nor the most massive. They are the quiet, unassuming cosmic misers, the red dwarfs. These miniature stars, some only a fraction of the mass of our Sun, are the longest living objects in the universe. But their incredible longevity is not magic. It is a masterpiece of thermal fluid dynamics. Unlike our Sun, which traps its unburned fuel in distinct static layers, a red dwarf is fully convective from its core to its surface. Its internal physics acts like a perpetually boiling pot of water. Helium created in the nuclear core is constantly churned outward, while fresh unburned hydrogen from the surface is continuously dragged down into the central fusion engine. Because of this ultimate thermodynamic efficiency, a red dwarf can burn almost 100% of its hydrogen fuel. While a medium-mass star like our Sun lives for a mere 10 billion years, a red dwarf can sip its fuel at a remarkably slow rate, surviving for trillions of years in the darkening void. As these ancient red sentinels become the last bearers of light, the very nature of reality will shift. The universe will transition from the violent, rapid, energetic bursts of its youth to a slow, methodical, and incredibly dim existence. The frantic pace of the cosmos will grind to a crawl. The total energy output of the entire universe will drop to but a fraction of a percent of what it is today. The galaxies will no longer be bright, sweeping spirals, but diffuse, spherical swarms of dim red dots, barely visible against the absolute black of expanding space. Because the universe continues to expand, driven by dark energy, the distances between these fading galaxies will grow so vast that light from one will never reach another. An observer looking up from a world orbiting a late-stage red dwarf would see a completely empty black sky stripped of all other galaxies. This inescapable scientific reality forces us to confront the profound philosophy of cosmic time. Look up at the night sky tonight. Breathe in the starlight. We are incredibly fortunate. We live in the brightest, most active, most chemically rich fraction of cosmic time. This golden age of light and warmth is nothing but a fleeting spark in the grand, staggering timeline of existence. The universe has a violent beginning, a brief, beautiful morning filled with stars, and an eternity of endless freezing night. The rest of eternity belongs to the dark. But just as we think the story ends with these fading red embers, mainstream astrophysics predicts an even stranger epoch. Next, we will uncover what happens to the last oases of warmth in the universe, and you will not want to miss how life might cling to existence around the corpses of dead stars. I used to think that the fading of the cosmic web would bring a swift and merciful end to life in the universe. But the reality of surviving around these dying embers is a terrifying testament to endurance. As the universe dims, the struggle for survival will reach unprecedented extremes. If biological or artificial intelligence exists in the deep future, they will be forced to migrate, abandoning their ancestral homes. The fading remnants of stars, specifically red dwarfs and white dwarfs, will become the absolutely final oases of warmth in a freezing, infinite desert. But surviving around these cosmic embers is fraught with peril and demands adaptations that defy our current understanding of habitability. It is a desperate cling to existence where the margins of error are practically non-existent, because red dwarfs are incredibly dim and cool compared to stars like our Sun. Their habitable zone, the precise region where liquid water can exist on a planetary surface, is pulled dangerously close. For a planet to capture enough warmth from a red dwarf to prevent its oceans from freezing solid, it must orbit closer to its star than Mercury orbits our Sun. But this vital proximity exacts a heavy and uncompromising gravitational toll. The intense tidal forces from the host star will act as an unyielding brake on the planet's rotation. Over millions of years, the star's gravity will drag against the planet's crust and oceans, eventually locking it in place. This phenomenon, known as tidal locking, means the planet will no longer experience the familiar cycle of day and night. The physical reality of a tidally locked world is a landscape defined by terrifying extremes. One hemisphere of the planet will face eternal scorching daylight, locked in a perpetual stare with the angry crimson eye of its star. The surface temperatures here would be blistering, capable of boiling away oceans and baking the crust into a desolate, cracked wasteland. On the exact opposite side of the planet lies a realm of eternal freezing night. This hemisphere never sees the star plunged into an endless shadow where temperatures plummet close to absolute zero, freezing atmospheric gases into solid snow that blankets a dark, jagged, icy terrain. You might think this leaves the entire planet completely uninhabitable, an orb divided equally between fire and ice. Yet between the boiling inferno and the frozen wasteland lies a narrow, precarious boundary known as the Terminator Line. This is the permanent twilight zone, and it could harbor the absolute ultimate refuge for life in the universe. The atmospheric dynamics in this narrow ribbon would be chaotic and extreme beyond human imagination. Ferocious hurricane force, winds driven by the immense temperature differential, would constantly roar from the day side to the night side. These unending gales would transfer crucial heat, potentially keeping the narrow ribbon of an ocean from boiling away entirely or freezing completely solid. Life here, if it exists, would evolve in a state of permanent sunset, bathed in a blood-red glow, clinging to the only temperate strip of land on a dying world. It is a twilight existence of fragile equilibrium, but it represents a fighting chance. However, even the tenacious red dwarfs are not the only potential shelters in the darkening void. Consider the tragic yet beautiful fate of our own Sun. Our star is too massive to share the incredible longevity of a red dwarf. In about 5 billion years after exhausting its core supply of hydrogen, our Sun will undergo a violent and terminal transformation. It will swell into a monstrous red giant, expanding outward to swallow Mercury, Venus, and likely Earth in a fiery apocalyptic embrace. After this destructive expansion, it will convulsively shed its outer layers, exhaling them into deep space to form a glowing, beautiful planetary nebula. What remains at the perfectly dead center will not be a functioning star but a dense glowing corpse. When the cosmic smoke clears, a white dwarf is revealed. A white dwarf is the exposed naked core of a dead star. It is an object of terrifying extremes, incredibly dense and fiercely hot. Imagine a sphere no larger than the Earth but packing half the mass of our entire Sun. The gravitational crush is so intense that normal atoms shatter, leaving a sea of carbon and oxygen nuclei swimming in a degenerate electron gas. A single teaspoon of white dwarf material weighs as much as an elephant. Crucially and tragically, white dwarfs no longer undergo nuclear fusion. They are entirely dead. The blinding white light they emit is merely the trapped residual heat from their previous active life, radiating slowly into the freezing vacuum of space. Could a highly advanced civilization survive here? Theoretically, yes, but it would require engineering on a staggering scale. The habitable zone around a white dwarf is incredibly tight, orbiting just millions of miles from the surface. A civilization facing the death of their star might attempt to engineer the migration of a rogue rocky planet using immense precise gravitational tugs to spiral it inward and settle it into a close, stable orbit around the glowing ember. This artificial oasis would provide heat and light, but this warmth comes with a strict, undeniable time limit. Because there is no active fusion engine to sustain them, white dwarfs are locked in a relentless one-way process of cooling. They are cosmic batteries slowly bleeding their charge into the void. Over hundreds of billions of years, the trapped heat inevitably dissipates. The blinding white sphere slowly cools, shifting its emission spectrum. It cools from bright white to yellow, then to orange, and eventually down to a dull, deep red. And finally, after an expanse of time that makes the current age of the universe look like a passing second, the white dwarf will cool entirely. It will vanish from the visible spectrum, completely transforming into a black dwarf. A black dwarf is a cold, invisible sphere of degenerate carbon and oxygen floating silently and blindly in the absolute dark. The transformation of the very last white dwarfs into black dwarfs marks a terrifying, irreversible milestone in cosmic history. It is the final extinguishing of the universe's natural light sources. The era of stars is officially over. The universe is now entirely pitch black. But even in the total absence of light, there is raw power waiting to be harnessed. When the last white dwarfs fade into invisible black dwarfs, the universe does not end. It simply undergoes a fundamental transformation. We enter the black hole era. Up until this point, the cosmos has relied on nuclear fusion as its primary engine for light and heat. But as stellar energy completely fades into the background, gravity steps out of the shadows to claim its absolute reign over the cosmos. The universe shifts from a paradigm of thermodynamic emission to one governed entirely by raw, unyielding gravitational energy. This marks a profound departure from everything we currently observe in the night sky. The energetic starbursts and the glowing nebulae are replaced by the silent geometry of curved space-time. When the James Webb Space Telescope looked deep into the cosmic dawn, it found something that challenged our initial models of cosmic evolution. It discovered supermassive black holes that were extraordinarily massive, existing far too early in the history of the universe. These early dark engines served as the gravitational anchors around which the first galaxies formed. They have been there since the beginning, directing the flow of gas and the orbits of billions of stars. And long after their host galaxies have died, withered, and faded to dust, these central black holes will remain. They outlive their stellar companions by orders of magnitude that defy ordinary human comprehension, standing as the most resilient structures ever formed by nature. In the deep future, the remaining galactic structures will undergo a slow, methodical collapse. Galaxies will cease to be vast, sprawling spirals of light, and will become dark, silent swarms of stellar remnants orbiting a central supermassive black hole. Over unimaginable timescales measured in quintillions of years, the dead remnants of stars, such as black dwarfs and neutron stars, will interact gravitationally. As they orbit, they continuously leak a tiny amount of energy into the fabric of space-time itself in the form of gravitational radiation. Gravitational waves are ripples in the geometry of space, predicted by Albert Einstein, and they carry energy away from any system of orbiting masses. This continuous emission of gravitational waves is a strictly inevitable consequence of general relativity. As these dead stars bleed orbital energy, their trajectories slowly and permanently decay. They imperceptibly spiral inward, executing a silent cosmic dance that lasts for eons. The distances between the stellar remnants and the central black hole decrease millimeter by millimeter over billions of years. Eventually, over timescales so vast they render the current age of the universe mathematically insignificant. These stellar corpses will cross the event horizon. They will be consumed by the central supermassive black hole, adding their mass and their angular momentum to the singularity in the center. This is the true reality of the black hole era. It is an epoch where these massive gravitational anomalies are the only significant organized structures left in a mostly empty, desolate void. The universe becomes a vast, expanding space populated only by isolated supermassive black holes, separated by distances so great that light could never bridge the gap between them. But to view black holes merely as cosmic destroyers or as endless pits of nothingness is to fundamentally misunderstand the nature of gravity and mainstream astrophysics. In a universe completely devoid of active stars, black holes become the ultimate resource. They are in fact the most efficient energy storage mechanisms permitted by the laws of physics. To understand this, we must look closer at the mechanics of black holes. Almost all black holes in the universe are not static, they are rotating. These are known in physics as Kerr black holes, and their spin carries an immense amount of angular momentum. Because of their extreme density and gravitational pull, they do not merely spin within space, they literally drag the surrounding fabric of space-time along with them. This phenomenon, known as frame dragging, or the Lense-Thirring effect, creates a distinct and fascinating region just outside the event horizon, known as the ergosphere. The mathematics describing this region are one of the most beautiful and rigorously tested aspects of general relativity. The ergosphere is a boundary where the rotational energy of the black hole forces space-time itself to move faster than the local speed of light. To an outside observer, it is physically impossible for any object within the ergosphere to remain stationary. Anything that enters this region is inevitably dragged along by the sheer rotational momentum of the black hole, regardless of how much thrust it applies in the opposite direction. However, the ergosphere is located strictly outside the event horizon, which means that unlike the interior of the black hole, an object can enter the ergosphere and theoretically still escape back into the wider universe, provided it navigates the orbital mechanics correctly. This specific physical trait fundamentally changes how we must view black holes in the deep future. For any form of intelligence or advanced civilization surviving into this era, a profound paradigm shift must occur. Passive natural survival is no longer an option because the universe will no longer passively provide warmth or light. When the energy of nuclear fusion is completely exhausted, advanced life must transition to active engineered survival. They cannot rely on geology or chemistry. They must rely on pure orbital mechanics and gravitational physics to extract the energy required to maintain their civilization and power their systems. They must look at the spinning boundary of a supermassive black hole not as a hazard but as the ultimate battery. The angular momentum stored within a Kerr black hole represents an astronomical reservoir of extractable energy far exceeding the total energy output of billions of stars. The civilization must adapt to the new rules of the cosmos, learning to manipulate orbital mechanics and extreme gravitational fields to harvest power directly from the rotation of space-time itself. This requires a level of engineering that operates on a galactic scale, treating gravity not as a force to be fought, but as a tool to be utilized. The black hole era is therefore not necessarily a dead end for complexity or intelligence. It is a period that demands the ultimate mastery of physics. The universe forces any surviving civilization to graduate from being harvesters of starlight to becoming engineers of gravity. The structures they would need to build and the physical processes they would need to exploit push the very boundaries of theoretical physics, but they remain firmly grounded in the established mathematical frameworks of general relativity. The next step in this evolution of survival involves a specific mechanism to tap into that ergosphere, a method to literally mine the rotational energy of the void and keep the lights on in a dead universe. How do you extract energy from an object whose defining physical characteristic is that absolutely nothing can escape its gravitational grip? The answer lies not in attempting to breach the event horizon, but in exploiting the violently twisting space just outside of it. You do not take energy from the singularity itself, rather you steal it from the kinetic rotation of space-time. Welcome to the absolute pinnacle of gravitational engineering. Welcome to the Penrose process. To comprehend this, we must first understand that a spinning black hole contains two distinct types of energy: its immense rest mass, which is forever locked behind the event horizon, and its rotational energy, which dictates the twisting of the ergosphere. It is this rotational energy which can account for up to 29% of the black hole's total mass energy that is completely available for the taking. First proposed in 1969 by the brilliant mathematical physicist Sir Roger Penrose, The mechanics of this theoretical process are a masterclass in exploiting relativistic physics. Imagine a highly advanced civilization that has successfully navigated the darkening universe. To survive, they fire a massive physical object, perhaps a hollowed-out asteroid, or a specially designed payload containing their waste material directly into the ergosphere of a rapidly spinning supermassive black hole. The trajectory must be calculated with a level of precision that borders on the divine, taking into account the immense frame-dragging effects that warp the very fabric of reality around the singularity. Once inside this gravitational maelstrom, where space itself is being dragged in a circle faster than the local speed of light, the object is triggered to violently split into two distinct halves. This separation is not random, it is the absolute crux of the entire operation. Through precise orbital mechanics and timed chemical or nuclear propulsion, one half of the original mass is deliberately sacrificed. It is pushed into a specific retrograde trajectory, moving against the immense rotation of the black hole. This complex maneuver forces the sacrificed half to adopt a mathematical state of negative mass energy relative to an observer in the outside universe just before it irrevocably crosses the event horizon and falls into the singularity. Because the fundamental laws of thermodynamics and quantum mechanics demand that the total energy of the physical system must be strictly conserved, the remaining half of the object undergoes a radical and explosive transformation. To balance the cosmic equation, this surviving half absorbs a massive instantaneous kinetic boost. It is violently ejected from the ergosphere, hurtling back into deep space, with significantly more mass energy than the original intact object possessed when it first entered the system. The escaping payload has literally stolen rotational energy and angular momentum directly from the twisting spacetime of the black hole. As a direct consequence of this grand cosmic theft, the rotation of the supermassive black hole slows down by an infinitesimal fraction. In exchange, the surviving civilization gains an astronomical amount of usable kinetic power. They have effectively turned the deadliest object in the universe into a colossal spinning flywheel. They can capture the escaping mass, harness its incredible velocity, and convert that kinetic energy into electricity to power their dying worlds. But utilizing the Penrose process with physical solid objects is merely the foundational step. It is logistically cumbersome and vastly inefficient compared to what the laws of physics truly allow. To completely conquer the dark and ensure survival for eons, a civilization must abandon physical payloads and build the ultimate machine, the black hole bomb. Imagine undertaking the most ambitious megastructure project in the history of the cosmos. A civilization constructs a vast perfect sphere of highly reflective metamaterial completely enclosing the spinning supermassive black hole. This structure is somewhat analogous to a Dyson sphere, but instead of being built to capture the thermal radiation of a living star, it is built around a sphere of absolute darkness to manipulate the quantum and relativistic fields of the void. The material engineering required to build such a mirror would be staggering, as it must withstand immense gravitational tidal forces and the absolute zero temperatures of the degenerate era without fracturing. This megastructure is fundamentally designed to act as an immense cosmic resonator. The process begins by firing a controlled beam of low-frequency electromagnetic radiation, essentially light or radio waves, through a designated mechanically operated opening in the spherical mirror. When this wave enters the ergosphere, it interacts with the twisting spacetime. Just as a physical object can steal rotational energy, the electromagnetic wave undergoes a process known in advanced physics as super-radiant scatterings. The wave siphons rotational energy from the black hole and emerges amplified, possessing a much higher amplitude and carrying significantly more energy than when it first entered the structure. The amplified wave then strikes the inner wall of the perfectly reflective spherical mirror. It bounces back, plunging straight into the ergosphere once again. it undergoes another round of super-radiant scattering, stealing even more energy and bouncing off the opposite wall. This creates a terrifying and magnificent feedback loop. The electromagnetic wave bounces back and forth, multiplying in strength with every single pass through the ergosphere. The wave grows exponentially rapidly, turning the dark, cold interior of the massive mirror sphere into an environment of unfathomable, blinding electromagnetic energy. If left completely unchecked, this exponential buildup of energy would become catastrophic. The internal radiation pressure of the amplified waves would eventually shatter the megastructure in an explosion of unimaginable magnitude, completely destroying the mirror and anything residing within light years. It would create a cosmic blast that could rival a supernova born entirely from the stolen spin of a dead black hole. But a civilization capable of building such a device would not let it become an actual bomb. By engineering precise mechanically timed windows in the mirror sphere, they can systematically siphon off vast beams of this amplified pure energy before critical mass is reached. They release just enough radiation into their collection grids to prevent the structure from detonating, harvesting the excess to power their civilization. This creates the ultimate perpetual power plant. This singular, breathtaking engine could provide enough uninterrupted energy to sustain trillions of digital or biological lives. It could power vast computational networks, maintain sprawling artificial habitats, and run incredibly complex simulated realities for billions of eons long after the final star has permanently died. It is the ultimate philosophical triumph of mind and engineering over a decaying cosmos. It is a profound testament to life's absolute refusal to surrender to the advancing dark, transforming the terrifying graveyards of dead galaxies into the most powerful sanctuaries of light ever conceived. To execute gravitational engineering projects of this staggering magnitude, the very definition of what constitutes a civilization must fundamentally evolve. In the 20th century, astrophysicist Nikolai Kardashev proposed a scale to measure a civilization's level of technological advancement based strictly on the amount of energy they are able to harness and utilize. A Type 1 civilization masters the energy of its home planet, a Type 2 harnesses the total output of its host star, and a Type 3 commands the energy of an entire galaxy. But in the encroaching gloom of the degenerate era, the traditional Kardashev scale becomes functionally obsolete. When active luminous energy is extraordinarily scarce and the stars are dead raw, energy output is no longer the ultimate metric of success. Therefore, Type 3 and theoretical Type 4 civilizations must be entirely reimagined. In the deep future, a civilization's supremacy is defined not by how much energy it can recklessly burn, but by its supreme godlike ability to manipulate the geometry of space-time to maximize thermodynamic efficiency and to successfully halt the relentless march of entropy on a localized galactic scale. This technological ascendancy does not happen overnight. It begins long before the absolute dark sets in during the twilight of the stelliferous era. Recognizing the inevitable heat death of the cosmos, an advanced intelligence will begin to hoard the universe's remaining resources. Before their host stars completely exhaust their nuclear fuel and fade away, civilizations will embark on the construction of stellar engines. Theoretical megastructures, such as the Shkadov thruster, represent the absolute pinnacle of stellar engineering. By constructing a colossal, incredibly thin parabolic mirror, perhaps half the size of a solar system, and placing it strategically over one hemisphere of their star, they can fundamentally alter the star's trajectory through space. The mirror does not completely enclose the star. Instead, it reflects the star's own immense radiation pressure and solar wind back upon itself. This creates a massive asymmetrical thrust. Over millions of years, this gentle, continuous pressure allows an advanced species to literally pilot their entire star system, complete with all its orbiting planets, across the interstellar void. They would roam the dying galaxy, intentionally navigating toward dense resource clusters, harvesting raw materials, sweeping up rogue planets, and forcefully merging with other star systems to consolidate their physical wealth before the universe goes completely cold. However, as the physical universe inevitably decays and ambient background temperatures plummet toward absolute zero, biological life itself becomes an unbearable liability. Biology is incredibly fragile. Flesh and blood require massive continuous infusions of warmth, water, and chemical energy just to maintain basic homeostasis. In a universe where every single photon of energy must be painstakingly extracted from the angular momentum of dead black holes, the biological form is wildly inefficient. To survive the deep freeze of the black hole era, intelligence will be forced to undergo a profound and irreversible metamorphosis. It is highly probable that advanced life will transition entirely into digitized post-biological consciousness. By abandoning the fragile organic bodies forged in the warm mud of their ancestral homeworlds, they eliminate the need for agriculture, breathable atmospheres, and temperate climates. Intelligence becomes pure data, intricate patterns of information processed within the heart of colossal cold-adapted supercomputers. To house trillions of these digitized immortal minds, civilizations will construct megastructures known as matryoshka brains. Imagine a Dyson swarm built not for capturing sunlight, but composed entirely of countless interlocking computational nodes orbiting the harnessed energy of a supermassive black hole. The genius of the matryoshka brain lies in its absolute mastery of thermodynamics. According to Landauer's principle in theoretical physics, there is a minimum theoretical amount of energy required to process or erase one bit of information, and this energy requirement is directly proportional to the ambient temperature of the environment. Therefore, the freezing, desolate environment of the dying universe is not a death sentence for a digital civilization. It is actually a computational paradise. In the near absolute zero of the deep future, computation becomes hyper-efficient, requiring only the faintest whisper of physical energy. Operating at maximum thermodynamic efficiency, these nested layers of computers would use the waste heat from the inner hotter layers to power the cooler outer layers, extracting every conceivable drop of utility from their gravitational energy source. Inside the silent, frozen metallic nodes of the matryoshka brain, rivers of golden light and electricity represent trillions of interconnected digitized minds. Divorced from the harsh, dying physical reality, outside these post-biological entities could construct and inhabit flawless simulated universes. They could perfectly recreate the bright, vibrant skies of the long-dead stelliferous era, living out subjective eons of peace art and intellectual pursuit. Because their perception of time would be dictated by the clock speed of their processors, they could experience millions of years of subjective existence in the span of a single physical second, or stretch a single thought out over millennia to conserve power. They would exist in a self-made paradise, a tiny, brilliantly lit digital terrarium floating in an ocean of infinite blackness. Yet to power these magnificent computational minds indefinitely, the ultimate fuel must be gathered and secured. In a supreme, breathtaking defiance of entropy, a Type 4 civilization might undertake the ultimate logistical project, physically moving and merging black holes. Using precise, multi-millennia gravitational tugs, perhaps utilizing networks of captured ultra-dense neutron stars, or the artificial manipulation of gravitational waves, they could intentionally alter the trajectories of isolated black holes across the vast galactic graveyard. Slowly, over billions of years, they would force these monstrous gravitational wells to migrate and merge together. By consolidating the scattered remaining mass and rotational energy of a dead galaxy into a single highly manageable supercluster, they maximize their power generation and drastically minimize energy lost to the expanding void. These colossal megastructures, from Shkadov thrusters to matryoshka brains and manipulated black hole clusters, are not merely the realm of idle science fiction. They are the strict, inevitable conclusion of applied physics when taken to its absolute extreme. They represent the ultimate manifestation of intelligence in the cosmos. They are the physical embodiment of life, absolutely refusing to go quietly into the dark. By bending the very fabric of reality, exploiting the most esoteric laws of thermodynamics and engineering, the geometry of space-time itself, consciousness mounts its final glorious stand, striving to keep the flame of awareness alive for as long as the unforgiving laws of physics will mathematically permit. But physics is a cruel and uncompromising master. Even the most perfect theoretical machines eventually break down. The colossal Matryoshka brains, with their trillions of digitized minds living in simulated paradises of golden light, cannot defy the strict laws of thermodynamics forever. They can stretch a finite amount of stolen rotational energy across an unimaginable expanse of time, simulating eons of existence within the span of a physical second, but they cannot create energy from nothing. Eventually, the rotational momentum of the captured supermassive black holes will be completely depleted. The immense cold-adapted supercomputers will power down one by one their artificial digital universes, fading into the dark like a fleeting dream upon waking. Even if the fundamental building blocks of matter do not decay, the physical structures of these impossibly advanced civilizations will slowly succumb to the relentless microscopic and unstoppable grind of entropy. Long after the great technological empires have faded into silent frozen dust, only the black holes will remain reigning in absolute silence over an entirely empty dead cosmos. But the ultimate staggering realization of theoretical astrophysics is that even these great gravitational leviathans, the undisputed and terrifying masters of the deep future, are not eternal. Long after the universe has completely forgotten the warmth and brilliance of the stelliferous era, it reaches its absolute ultimate limit. For decades in the 20th century, physicists believed that black holes were cosmic dead ends, ultimate gravitational traps from which absolutely nothing, not even a whisper of light, could ever escape. However, it was the brilliant theoretical physicist Stephen Hawking who made the groundbreaking realization that would seal the ultimate fate of the cosmos. Hawking understood that to truly comprehend the extreme mind-bending environment of an event horizon, one could not rely on the mathematics of Einstein's general relativity alone. He realized that the grand sweeping gravitational curves of Einstein must inevitably collide with the microscopic, chaotic, and probabilistic rules of quantum mechanics. When you combine these two monumental pillars of modern physics at the very boundary of a black hole, you discover a profound and terrifying truth. The black hole is leaking. To understand how a black hole, a devourer of worlds, can slowly dissolve into the void, we must first change our fundamental understanding of empty space itself. In the strange realm of quantum mechanics, empty space is never truly empty. At the most microscopic fundamental level of reality, the quantum vacuum is a seething, turbulent, and violently boiling ocean of potential energy. Governed by Werner Heisenberg's uncertainty principle, space is constantly alive with subatomic fluctuations. Pairs of virtual particles, one composed of matter and one of antimatter, are constantly popping into existence from absolute nothingness. They borrow a tiny, microscopic fraction of energy from the universe exist for a fleeting, entirely imperceptible fraction of a second, and then immediately crash back together, annihilating each other to perfectly repay their energetic debt. This subatomic dance happens everywhere in every single cubic centimeter of the universe all the time, completely unnoticed. But when this localized quantum fluctuation occurs exactly on the razor-thin, unforgiving boundary of a black hole's event horizon, something miraculous and absolutely devastating happens. Imagine a pair of these virtual particles bubbling up exactly on this invisible threshold. Before the two particles have the chance to find each other and annihilate in the dark, the immense, overwhelming tidal forces of the black hole's gravity violently intervene. One particle is caught in the inescapable gravitational grip, and is brutally pulled past the event horizon, falling forever into the central singularity. Its partner, suddenly completely stripped of its pair, cannot annihilate. It is violently flung outward into the frozen expanding expanse of deep space. Because the universe strictly demands that all energy must be conserved without exception, this escaping particle is forced to become a real physical particle carrying positive energy away into the endless void. This escaping ghostly stream of particles is what we call Hawking radiation. The escaping particle carries away positive energy, which means the particle that fell into the black hole must, from the mathematical perspective of the outside universe, carry negative energy. As this negative energy falls into the singularity, it actively and continuously subtracts from the total mass of the black hole. The mathematics governing this thermodynamic decay are beautifully precise, fundamentally absolute, and elegantly simple. In a single breathtaking equation, Stephen Hawking united the speed of light, the universal constant of gravity, the microscopic quantum scales of Planck, and the thermodynamics of Boltzmann. When translated into words, this mathematical masterpiece dictates a terrifyingly simple rule. The temperature of a black hole is strictly and inversely proportional to its mass. The larger and heavier the black hole, the colder it is, and the slower it leaks these particles into space. For the colossal supermassive black holes that once anchored the centers of dead galaxies, this evaporation process is terrifyingly, agonizingly slow. Their temperature is just a minuscule fraction of a degree, above absolute zero, making them colder than the ambient temperature of the dying universe around them. To completely evaporate a single supermassive black hole through the whisper of Hawking radiation takes an expanse of time that completely shatters the human mind's capacity for comprehension. It will take roughly a Google years. That is a number 1 followed by 100 zeros. If you were to take a pen and write a 0 on every single atom in the entire observable universe, you would run out of atoms long before you could write down a number this unfathomably large. Yet against the infinite, relentless backdrop of eternity, even a Google years must eventually pass. As the black hole spends uncountable eons slowly bleeding its mass into the silent void, its temperature begins to fundamentally change. The mathematics dictate that as the black hole loses mass, it gets hotter, and as it gets hotter, it evaporates faster. This creates a runaway, unstoppable exponential effect. After practically an eternity of imperceptibly slow decay, the black hole shrinks down to the mass of an asteroid, then a mountain, then a boulder. As it becomes microscopically small, its temperature spikes to trillions of degrees. It becomes blindingly white-hot and violently, chaotically unstable. In its absolute final, desperate fraction of a second, the black hole ends not with a slow, quiet fade, but with a colossal, violently destructive flash of gamma rays, expelling the very last of its mass energy into the freezing void. This final, brilliant flash of blinding light will be the last significant macroscopic event in our entire universe. But this violent ending brings forth the ultimate unresolved conundrum in theoretical physics, the information paradox. When that final black hole evaporates, what happens to everything that ever fell inside it? What happens to the crushed remnants of ancient dead stars, the absorbed rocky planets, and the theoretical matryoshka brains holding the digitized precious memories of trillions of souls? The core unbreakable tenet of quantum mechanics is that information can never be fundamentally destroyed. But if a black hole completely evaporates into a completely random, featureless soup of thermal radiation, that information appears to be permanently erased from existence. Modern physics remains deeply and fiercely divided. Some believe the information is subtly encoded in the outgoing Hawking radiation, perfectly scrambled but mathematically preserved for eternity. Others believe the information is lost forever, meaning the universe suffers from a terrifying, irreversible, and absolute cosmic amnesia. Regardless of the paradox, the end remains exactly the same. As the very last black hole detonates and slowly evaporates into a thin, ultra-low energy soup of dormant photons, the universe will finally reach a state of maximum entropy. We call this the heat death. All temperature differences will have completely and permanently vanished. No more work can ever be done. No more energy can ever be extracted. The Great Sleep begins. Nothing happens, and it keeps not happening forever. Time itself loses all practical meaning, because without change, without the movement of energy from one state to another, time simply does not exist. Yet this ultimate desolate freeze is not a tragedy to be mourned. It is a beautiful, magnificent completion. The physical luminous structures of the stelliferous era may be entirely gone, and the heavy gravitational geometry of the degenerate era may be permanently erased, but the fundamental quantum fields remain intact. The magnificent underlying mathematics that allowed the universe to exist in the first place, that allowed gravity to meticulously sculpt the sprawling galaxies, that allowed humanity to build the James Webb Space Telescope, to peer back in time, and that gave us the profound fleeting privilege to understand our own inevitable fate. Those mathematics are utterly eternal. The universe will sleep in perfect, undisturbed equilibrium, but it happened. We were the universe's unique, brilliant way of experiencing itself. We were the cosmos waking up, looking in the mirror, and marveling at the brief, beautiful spark of light before the eternal dark.